Well, we ended our last video with this problem. How do you find the range when the ball is kicked at 25 degrees at 20 meters per second? We got the components. We said T up is Vy initial divided by G, giving us 0.862 seconds. The time up is the same as the time down, giving us 1.724 seconds for what we call the time of flight. And the whole time it's in the air, it's moving 18.13 meters per second sideways. This gives us a range of 31.3 meters. Now, could you figure out the height maximum? Well, that's the same thing as saying, how far could it fall in the time down? Time down is the same as the time up. Hey, we got 3.64 meters. Okay, here's plan B. Take your initial velocity in the y direction. The final velocity at the top is 0. Use your average velocity. Multiply it by the time up, you're going to get your H max. That's 4.225 meters per second times 0.862 seconds. Yep, we get 3.64 meters. Want to do it the hard way? Well, go negative 1/2 gt up squared, and negative because gravity's down, because this initial velocity is a positive going up. Multiply that times the time up. And you still get 3.64 meters for the maximum height. Well, I'll tell you what this is good for. You can put in any value of time and calculate the height. How high is the ball? At 1.5 seconds. We get a height of 1.65 meters. It has to be over here on its way down because we're past the halfway time. Exactly where along here? Just use this formula. You can just find the x value from the horizontal velocity times whatever time we're at. So we're traveling 18.13 meters per second horizontally for 1.5 seconds. Yeah, we get 27.2 meters, so we're almost all the way back over here. Let's take a look at the formula that tells us how high we are vertically and how far we've traveled horizontally. Let's move this term over here. What's missing? Yeah, a 1/2 AT squared. Why don't we have that? Because everything is in the x direction. That acceleration in the x direction is 0. Again, because there's no forces horizontally, only vertically, and that's why we have the acceleration term in the vertical position formula. Now, don't get these mixed up either. The horizontal velocity goes here, the vertical initial velocity goes here, and sometimes kids use this for these velocities. Big mistake. Let's try a harder problem. We're going to launch the ball at a height of 4 meters above the ground at 10 meters per second at an angle of 30 degrees. We have to find the range. Now, can you take a look at this and see that going up and going down are no longer symmetrical? The range is still going to be equal to that constant horizontal velocity times the time of flight. That's the total time. I'm going to have a time up, but a longer time down to add together for this time of flight. Well, we've got our components, and that is going to go right here. And now we'll get the time up. Vy over g, and I get 0.5102 seconds. And I'll use that to get the H max. Just take the average velocity on the way up times the time up. You get 1.2755 meters, but don't forget we're on top of a cliff or something here. We got to add the 4 meters. H max is 5.2755 meters. And that's how far down we have to fall, which I'll use to calculate the time down. That gives me a time down. I have my time up. I add them together and I get 1.5478 seconds. And I get 13.4 meters for the range. Well, for some kids, that's just too many steps. So they'd rather do this. We have a displacement that's negative. We have an acceleration that's negative, but we have a positive initial velocity. And unfortunately, you have to use the quadratic formula to solve for t. If you do it, you're going to get 1.5478 seconds. So you'll get the same range. What about the impact velocities? Of course, the horizontal velocity has never changed. It's still 8.66. But what about that guy? You could use the acceleration in the y direction. That's down, that's up, solve for the final velocity in the y direction. But that is the time of flight to get us to here. And we get a negative 10.17 meters per second. And we get 13.35 meters per second at 49.5 degrees below the horizontal. Now, there's tons more problems like this to practice in the chapter notes and in the worksheets that are in the chapter notes and the other worksheets that I sent you.